This lesson is a continuation of solving a system of equations using the elimination method. In this particular lesson, you will have to use multiplication prior to using the elimination method. So let's take a look at some examples to see how this works. If you look at example 1, you can see that the equations are set up for the elimination method, meaning the x's are lined up and the y's are lined up on the left side of the equal sign, and our constants are on the right. And this is the format that you want your equations in order to use the elimination method. But when using the elimination method, you're going to focus on the coefficients of x and the coefficients of y and see if you add the like terms together, if you can eliminate one of the two variables. In this particular example, you cannot eliminate the x's because 1 plus 1 is 2. So therefore, we cannot eliminate the x. 3 plus 6 is 9 for the y's, so we cannot eliminate the y's. Therefore, we cannot begin the elimination method until we've used multiplication to create opposites either with the x's or the y's to allow us to eliminate one of the two variables. So the way that we do this is we have to think of what we can multiply, in this case, one of the two equations by, so that we can eliminate the x's. So we want to multiply all three terms by a number so that we can make the first term a -1, which will allow us to eliminate the x's. So how can we make the the 1 a -1? We simply multiply each term by -1. So let's see what these equations would now look like. Our first equation, if we multiplied all three terms by -1, would become a -x minus 3y equals -3. Our second equation we can leave the same. So now you can see that the coefficients of the x, -1 and 1, if we were to actually add our like terms, would add up to 0, which would eliminate the x's, which is our goal for the elimination method. So we can now finish the process of finding the solution using the elimination method. So -1x plus 1x is 0, so we can eliminate the x's. We will then add the like terms, starting with the y's. So -3y plus 6y equals 3y. And -3 plus 3 equals 0. If we then divide both sides by 3, y equals 0. So we know half of our solution. We know that y is 0. So just as we've learned in previous lessons, we will now pick one of the original equations. So I'm going to go ahead and pick the second equation, although it really doesn't matter. And because I know that the y value is 0, I can replace the y with 0 in the equation. From here, I can simply solve for x. So x equals 3. Oops. Let me just change that real quick. So our solution to this system of equations is 3, 0, which means if we were to graph these two equations, that their point of intersection would be at 3, 0. Now we can simply plug these values back into the original equations to double check our answer. So let me scroll down and refresh your memory on this process. So as we plug in the solution back into the two equations, in the first equation, we will plug 3 in for x and 0 in for y. We will then simplify the left side of the equal sign, which would be 3 plus 0, or 3, drop down the right side, and make sure that they are equal. Then we will do the same to the second equation, x plus 6y equals 3. We will replace the x with 3 and the y with 0, and simplify this, which is 3 plus 0, or 3, and drop down the right side of the equation and make sure that they are equal. And in both cases they are, so we can be confident that our solution is correct. Let's now take a look at a second example. In this second example, notice that in the second equation we have a fraction. So you might want to clear that fraction by multiplying all the terms by 2. So this would give you negative 6x minus y equals 2. Then you can simply drop down your second equation, which would be 2x minus y equals 0. Now again, before you can add all the like terms vertically, you need to make sure that either the coefficients of x or the coefficients of y are opposites and add up to 0 so that we can eliminate one of the two variables. You can see that in neither case do the coefficients add up to 0. So therefore, we will have to use multiplication to create opposites for one of the two variables. So let's go ahead this time and use the second equation and focus on the y's because they are both 1s. So it'd be very simple to create opposites for the y's. All we would need to do is make one of those 1s a positive. So to do that, we simply need to multiply all 3 terms in the second equation by negative 1. So this would come out to negative 2x plus y equals 0. I'm going to draw a line so you don't get confused as to what our equations are that we're using. So I'll drop down that first equation, negative 6x minus y equals 2. So now you can see that the coefficients of y are opposites. We have a 1 and a negative 1 and add up to 0. So this will allow us to eliminate the y's and solve for x. So we would have negative 8x equals 2. If we divide negative 8 and then reduce 2 over negative 8, we would get negative 1/4. So this would be half of our answer. And this value is for x. So we then need to find the value of y. So we need to choose one of the two original equations. It looks like the first equation would probably be the easier of the two to use. Now we know that our value of x is negative 1/4. So we can replace the x with negative 1/4. So it'd be 2 times negative 1/4 minus y equals 0. So because we only have a y, we can now solve for this variable. So we need to first multiply 2, and we'll make it 2 over 1, times negative 1/4. So let's cross cancel the 2 and the 4. And then when we multiply what remains, we would have negative 1/2 minus y equals 0. From here, just add 1/2 to both sides of the equal sign. So negative y equals 1/2. We're almost done. Because our y is negative, to make it positive, you can either multiply each term by negative 1, divide each term by negative 1, or the easiest thing to do is simply change the sign of every term. So in this case, the y would become positive, and the 1/2 would become negative. So up at the top here, we now know our y value is negative 1/2. So it appears that our solution to this system of equations, or its point of intersection, would be at negative 1/4 negative 1/2. We will now scroll down and plug in these values back into both equations and see if our answer is correct. Starting with our first equation, we will go ahead and plug in the values negative 1/4 for x and negative 1/2 for y. So this would give us 2 times negative 1/4 minus negative 1/2 equals 0. So simplifying the left side of the equal sign, 2 times negative 1/4, if we cross cancel, would give us negative 1/2. And then here we have negative negative 1/2. So our double negative, we will make a plus 1/2. And this adds up to 0 because opposites always add up to 0. Then drop down the right side and you can see that the left and right side are equal. So far it appears that our solution is correct, but we cannot be for sure until we plug it in to the second equation. So negative 3 times negative 1/4 minus, this is going to be a little confusing, so what you may want to do is replace the y, or put a 1 in front of the y, and it's actually 1/2 times, and then replace the y with negative 1/2, and write it that way. You can use parentheses if you want. So look what I did with that y, just to make it simplify it so you don't have a fraction in the numerator of a fraction. Now let's simplify the left side of the equal sign. We cannot cross cancel when we multiply negative 3 times negative 1/4, so we will simply multiply the numerators and the denominators, giving us positive 3/4. In our second set of fractions, again, we cannot cross cancel, so we will multiply straight across. A negative times a negative is a positive, and when we multiply the numerators and the denominators, we get 1/4. Because these fractions have a common denominator, we can go ahead and add the numerators, giving us 4/4, or 1. If you drop down the right side of the equal sign, that also equals 1. So we can see our values match. So we can be confident that negative 1/4, negative 1/2 is the point of intersection for this system of equations. Let's go ahead and move to example 3. In these last two examples, I will go ahead and use multiplication and then the elimination method to find the solution to the system of equations. However, I will not be plugging that back in to double check it because I think that you should already understand the process at this point. So let's go ahead and look at our two equations. Notice that the x's are lined up and the y's are lined up in alphabetical order on the left side of the equal sign. But if you were to add the x's and then add the y's, neither variable would cancel. So we need to look at the coefficients of the x's and the coefficients of the y's and see how we could use multiplication to create opposites so we could eliminate one of the two variables. Now, if you focus on the x's, which has a 9 and a 3, you would want those to add up to 0. So they need to be opposites, like 9 and negative 9, or 3 and negative 3. So if you were to focus on the x's, the easiest thing to do is to keep the first coefficient of x 9, but to change the second to a negative 9. To do this, we would need to multiply it by negative 3. But when you do this, again, you must multiply every term in that equation by negative 3. So when you do this, we would get negative 9x minus 18y equals negative 6. We would then drop down the first equation, and you can see that we can now begin using the elimination method by eliminating the x terms because they add up to 0. So negative 9x plus 9x is 0. When we add the y terms, negative 18 minus 3 is negative 21y. And then negative 6 plus 20 equals 14. We will then divide negative 21 and then reduce our fraction to lowest terms by dividing the numerator and the denominator by 7. This would give us negative 2/3 for our value of y. We then need to choose one of our original equations and plug negative 2/3 in for y. I'm going to go ahead and choose our first equation, 9x minus 3y equals 20. So I will replace the y with negative 2/3 because we found that to be its value in the first half of this problem. So we first would want to multiply negative 3 times negative 2/3. So a negative times a negative is a positive, and if you put a 1 under the 3, you would then be able to cross cancel the 3's, leaving you with 2 over 1, which is just 2. You can then subtract 2 from both sides of the equal sign. So we have 9x equals 18. Divide 9, and x equals 2. So our solution to our systems should be 2 and negative 2/3. Now again, to double check this, you can either plug these numbers in visually if you have that ability, and if you plug them in to the first equation for the x and the y, you can calculate the left side and see if it equals 20. And as I visually do this, I can see that it does. And then you can do the same to the right side, the second equation. Plug a 2 in for x and a negative 2/3 in for y. And if you were to simplify this, it should equal 2. And again, I can see as I visually plug it in that it will in fact equal 2. Let's take a look at our last example. The last example requires the most steps, because as we look at the coefficients of x and the coefficients of y, you can clearly see that we cannot eliminate either variable. Also, there is no number we can multiply all the terms in just one of the equations and create opposites. So we're going to have to use multiplication for both equations. So I'm going to focus on the coefficients of x, although we could do the coefficients of y. Because the coefficients of x are smaller numbers, it's typically easier to work with these numbers. So 2 and 3 both go into 6. So if I can make one of the coefficients 6 and one of them negative 6, I would then be able to eliminate the x's. So let me focus on the top equation, and I'm going to make that 2 a 6. To do that, I'm going to multiply it by 3. And again, I need to do that to every term in the equation. For the second equation, I want to make the coefficient of x a negative 6, so that we have a 6 and a negative 6. So to do this, I need to multiply it by negative 2. So I will do that to all of the terms. So I'm going to be changing both equations. So my first equation will now be, when I multiply each term by 3, 6x plus 18y equals 12. The second equation would be negative 6x plus 14y equals negative 12. So notice that the coefficients of x are now opposites, and I can go through the elimination process and eliminate the x terms. From there, I can add the y terms, and 18 plus 14 is 32y, and then 12 plus negative 12 is 0. I can then divide by 32, so my y value is 0. Now I can choose one of my original equations, and I will pick the first one. And now that I know that y is 0, I can replace that y with 0 and solve for x. So if I simplify the left side of the equal sign, I would have 2x plus 0 equals 4. So then I have 2x equals 4. And to finish, I'll divide by 2, so x equals 2. So my solution to this system should be 2, 0. And as I visually plug in the 2 for x in the first equation and the 0 for y and calculate the left side, it does equal 4. And in the second equation, I visually plug in 2 and plug in 0 and calculate the left side, and that does equal 6, which confirms that my solution to this system of equations should be correct. And this completes the lesson on solving a system of equations using the elimination method.